Section 11.2, we're going to look at properties of tangents. So in section 11.1, we talked about what a tangent was. Now we're going to look at properties of tangents. So if a line is tangent to a circle, then it is perpendicular to the radius drawn at the point of tangency. So we can see this tangent line L, the point of tangency is at B, and that means that this is a 90-degree angle. So the radius and the point of tangency make a 90-degree angle. So there we go. There's a note on your notes where it says note. Oh, I think that's meant to show you that this is the symbol for perpendicular. Tangents and right triangles. So here, AC is tangent to circle B at point C. So since it's tangent at point C, we know that the radius and the tangent line make a 90-degree angle. Therefore, we have this right triangle here. We want to find BC, so I'm just going to call this X. So if we have a right triangle, the way that we find a missing side length is by using the Pythagorean theorem. We know that hypotenuse squared, hypotenuse is across from the 90-degree angle, equals leg squared plus leg squared. Okay, so 13 squared is 169 equals x squared plus 144. Subtract 144 from both sides, and we get 25 equals x squared. To get, that's really messy, sorry guys. 25 equals x squared. To get x by itself, we're going to square root both sides because that's its inverse operation. And we get 5 equals x, or in this case, BC. We called BCX. So BC, we can just say BC equals 5. That looks like 0.5. There we go. BC equals 5. So because of our theorem, we knew this was a 90-degree angle, which allowed me to use Pythagorean theorem to solve for BC. You try. So the important part here is that they tell you that AB is tangent. Because it's tangent, this is a 90-degree angle. Therefore, we can set up Pythagorean theorem that hypotenuse squared equals, 15 is not the hypotenuse. Sorry, guys. Hypotenuse is across from the 90-degree angle. So hypotenuse squared equals leg squared plus leg squared. So 17 squared is 289. And 15 squared is 225. So we subtract 225 from both sides, and we get 64 equals r squared. Square root both sides, and we get 8 equals r. So again, because of what we just learned in that theorem, we knew that this was a 90-degree angle, which allowed us to use Pythagorean theorem. Now, we're going to get into it's a little bit harder here. So you're standing at point C, right here, 8 feet away from a silo. So right here is just right here is 8 feet. The distance to a point of tangency, so from you to this point of tangency, is 16 feet. What is the radius of the silo? Remember, radius just goes from center to an endpoint on the circle. So both of these are considered the radius, and they're the same distance. Now, same thing that we just did, because we have a right angle, we can use Pythagorean theorem. The only trick here is the length of the hypotenuse. So my hypotenuse goes all the way from A to C. So we have this part of our hypotenuse, which is R, and then we have this part, which is 8. So the whole length of my hypotenuse from A to C is really R plus 8. We have to add them to get that total length. So my hypotenuse is R plus 8. So we're going to take our hypotenuse squared, and that equals leg squared plus leg squared. Okay, so that's the hardest part of setting these up. Now, if you guys remember from Algebra 1, to square something means to multiply it by itself. So we're going to do R plus 8 times R plus 8. And you're like, oh, what do I do now? Do you guys remember FOIL? First, outer, inner, last. It's really just distributing. So r times r, first times first is r squared. Outer is r times 8, so that's 8r. Inner is 8 times r, so that's plus 8r. And last times last is 8 times 8, which is 64. So that's everything on the left side of my equation. And then I still have r squared plus 16 on the right side of my equation. Now what we want to do is, let's combine like terms here. So we're going to simplify the left side. 8r plus 8r is 16r. So we really have r squared plus 16r plus 64 equals 16. Now I want to try to get, not 16, sorry, equals r squared plus 16. Now I want to try to get all of my r terms on one side because I want to solve for r. So I'm going to subtract r squared from both sides, and you can see what's r squared minus r squared? That's 0, right? 1 minus 1, that's 0. So we have 16r plus 64 equals 16. So now we're just trying to solve for r, so we want to isolate our variable here. So I'm going to subtract 64 from both sides, and we get negative 48. Oh, I made a mistake. Oh, all right. I'm not going to restart the video, but Pythagorean theorem says the hypotenuse squared equals leg squared plus leg squared. I dropped this right here. Do you guys see? I dropped the squared on the 16. And it does make a difference. I knew I made a mistake because the radius can't be negative. So I was like, what did I do wrong? So yeah, I didn't square the 16. I did in the beginning and then I dropped it. So actually 16 squared here should be 256. Now this makes more sense because now my r value won't be negative. All right, 256 minus 64 is 192. So 16r equals 192. Divide both sides by 16, and we get r equals 12. So my radius is 12. Are there units on this problem? Yes. So we can add in a feet there. All right, these are by far the hardest problems of this section. So I'll do another one with you guys. Because AB, line AB is tangent, we know that the radius and the tangent line AB make a 90-degree angle. Okay, here's my tangent and here's the radius. So that's where the 90-degree angle is. So across from the 90-degree angle is my hypotenuse. So my hypotenuse here is from C to B, which is r plus 9. So hypotenuse squared equals leg squared plus leg squared. So to square something means to multiply it by itself. You do not want to distribute the squared, okay? We want to make sure you do r plus 9 times r plus 9. And now let's FOIL. First times first, r times r is r squared. Outer, r times 9 is 9r. Inner, r times 9 is 9r. Last times last, 9 times 9 is 81. And then this time I'm not going to forget to square the 21. 21 squared is 441. Let's combine these like terms here. 9r plus 9r is 18r. So we really have r squared plus 18r plus 81 equals r squared plus 144. Or sorry, I'm about to switch up my numbers here. 441. And now this is always going to happen. Let's put r squares on one side. R squared, they're always going to cancel. That's just 0. And so we are left with 18r plus 81 equals 441. Now this is just an equation where you have to solve for r. So subtract 81 from both sides, and we get 18r equals 360. Divide both sides by 18. and we get r equals 20. So my radius is 20. All right, so now we're going to move on to something else new. There's actually two new things. We're going to verify using properties of tangents. So how can you show that tangent EF must be tangent to circle D? Well, if it's tangent, then we want to prove that this is a right angle. Now, how do we prove that's a right angle? We have to show the converse of the Pythagorean theorem. Converse of, I'll just say PT for Pythagorean theorem. So what we have to show is, does the hypotenuse squared equal leg squared plus leg squared? So big question marks there. If we can show that that's true, then we can show that tangent EF must be, that line EF must be tangent to circle D, because that would mean that there's a right angle here, and that would prove that it's tangent. So big question mark here. We want to know, is this a right angle? All right, so let's check. 15 squared is 225, 9 squared is 81, and 12 squared is 144. If you add 81 plus 144 together, you do get 225. That's a true statement, right? 225 equals 225. Therefore, we know that this is a right angle, and therefore we know that line EF must be tangent to circle D. So that's all you need to show. You need to show that the Pythagorean theorem holds true. If it doesn't, and you get two things that aren't equal, then it's not tangent. So here's another example. They give you, let's see, AB and BD both equal 5. So from here to here is 5, and B to D is 5, and then they tell us that A to D is 7. So we want to know the radius here and the maybe tangent line here, do those make a 90-degree angle? Well, how do we check? So does hypotenuse squared equal leg squared plus leg squared, right? If it does, then yes, it's tangent. If it doesn't, then no, it's not tangent. So 49 equals 25 plus 25. Does 49 equal 50? No, 49 does not equal 50. Therefore, no, BD is not tangent to circle C, because the Pythagorean theorem wasn't true. So that's not actually a right angle. Even though it might look like it is, it's not. All right, last theorem, 11.3. If there we go. Okay, so I need to define a tangent segment first. It's a segment with one endpoint on the circle and one at a point outside the circle. So this is a tangent segment. This is a tangent line. This is tangent line AB, but a tangent segment is just a segment of that line with one at the point of tangency and one not at the point of tangency. So this is called the tangent segment. So if two segments from the same point outside the circle, for example, that they're talking about point S, so from the same point outside the circle, if they're both tangent to the circle, so you can see these are both tangent to the circle, then they are congruent. They're the same measure. So find the value of x. They're both tangent. AB is tangent and AD is tangent, and they meet at the same point A, therefore they're congruent. If they're congruent, that means they're the same measure, which means that I can set them equal. And now we can just solve for x. And that's it. So find the value of x, x equals 4. All right, they're both tangent to circle A. They both meet at point C, so therefore these are equal. So to find the value of x, I can set them equal because they're congruent. And we get x equals 3. And that's it. I'm going to look over the homework with you. All right, so I'm actually going to have you skip. You don't have to do 1 through 4. Don't worry about that. Oops, sorry. Actually, or you don't have to do 5. So yeah, don't worry about 1, 2, 3, 4, and 5. So I want you guys to just start at 6. JK is tangent to line C. Find the value of R. If they're tangent, that means that the radius and the line of tangency make a 90-degree angle. So therefore, you just have to correctly identify the hypotenuse. So you know hypotenuse squared equals radius squared, or sorry, hypotenuse squared equals leg squared plus leg squared. Okay, so then you can solve for R. Same thing here. Radius and the tangent line are going to make a 90-degree angle. So hypotenuse squared equals leg squared plus leg squared. And you guys can do number 8. Number 9, they're both tangent to angle C, which means that these are congruent, so you can just set them equal. And we're done. Same thing, these are congruent, so you're going to set them equal. And 11, same thing, these are congruent, so you can set them equal. So that part's pretty quick. Same thing here. These are tangent, so they're congruent, so you can set these equal to each other. And then determine if line AB is tangent to the circle using Pythagorean theorem. So this is where you want to check. This is I want to check, is this a right angle? Well, how do I know? Does hypotenuse squared equal leg squared plus leg squared? Question, question, question. If it does, then it is tangent. If it doesn't, then no, it's not tangent. So I'll just show you guys, we want to check, is that a 90-degree angle there? Is this a 90-degree angle here? Is this a 90-degree angle here? So that's what you guys are going to do for this back side. And then don't worry about 5, 6, 7, and 8. This is just finding x. So this looks like the 90-degree angle. So hypotenuse squared equals x squared plus 14.4 squared. But you guys do not have to worry about doing these numbers. So I just want you guys to complete, and I'll make a new worksheet for you. I just want you to complete these 6, this one, and these 4. Okay? Again, let me know if you have any questions.